PEP 750 T-strings has been accepted and implemented in CPython, and I'm going to walk you through what it is, how it works, some example use cases, the good, the bad, and finally, not that you asked, but my opinion on this PEP. Anyway, let's jump into it. So, since it has just landed, it is not actually in a released version of Python. Fortunately, there are a couple ways you can get access to it. One is via Dead Snakes, which is a PPA for Ubuntu that I maintain, which provides nightly builds as well. And so if you want, you can add apt repository PPA dead snakes /nightly. And then if you accept that and then apt install Python 3.14 on a LTS release, on 3.14, well, specifically these LTS releases, you'll have access to a Python 3.14, which has access to T-strings. If you're in the future, which is entirely likely, you may already have access to a release version of 3.14, but right now it is right before beta 1, the beta freeze, and some number of commits after alpha 7. But anyway, this is a version of Python which has access to T-strings. Oh, I did 3.12. I was like, wait a minute. The entire point of this video is that this is available. There we go. Okay, so that out of the way, I'm actually going to be using a different build of Python in a virtual env that I've set up beforehand, so it doesn't matter. Anyway, so let's talk about T-strings, PEP 750 template strings. The entire idea behind PEP 750 is to enable a succinct syntax for building out templates that could be reinterpreted in different ways. And when I talk about templates, I'm talking about ways to basically jam strings together with data and process the data in a way that's context relevant. I'll show you some examples in a bit, but first I want to talk about inspiration for the syntax, or at least one of the other languages that implements something similar. Oh, and another part of T-strings, I guess I should talk about before we move on, is there is a new module along with it as well. There is the string.templatelib module. And this basically just exposes the same types that templates produce when you call them. We noticed earlier when I just did t hello, we get a template object back. And that type is exposed inside this templatelib module. There's also interpolation, so well, this isn't going to work, but this way. You can see interpolations also get into the template object at the end. And so those types are exposed in templatelib. And there may be other things exposed here later. You can see there's already an unpickle function due to pickle nonsense, but that's a whole different thing. All right, let's talk about inspiration. First off, at least to me, the language that I think is as similar to Python as possible and has a feature as similar to Python is JavaScript, which also has a function called template literals or template strings, which, yeah, Python, same name here. In JavaScript, this sort of looks the same, and you may, if you've ever worked with JavaScript, you'll notice that there is a backtick, and it is very frequently used to jam strings together like this. You see, this is a template literal in JavaScript. This is almost identical to an f string in this way, but you can actually use a tag on the front of this to have it call a function. And so I know this isn't a video about JavaScript, but bear with me for a second. If you make a function which has strings and, I don't know, let's say arg1, arg2, for instance, and we're just going to console.log and not actually implement a function here, but and actually it's any number of positional arguments here, which is a little bit quirky, and I actually think Python did a better job here than JavaScript does here. But if you tag your template with a function name here, this function will get called with an array of all of the strings, the various, let's put another string at the end here, and then any of the arguments. You'll notice here that I only have one interpolation, so arg2 will actually be undefined. You can see here, this is the array of strings, first object, and then undefined. Anyway, JavaScript is another language which implements these, takes some different approaches to how they are handled, but I think is a decent example of some inspiration. Now, I've written a fair amount of JavaScript and TypeScript, and I think I can count the number of times that I have used a tagged literal in JavaScript. I think I've only used it once. And the time I used it once, I didn't need to. There were much better ways to do what was being done there. But I wanted to learn the feature. Anyway, inspiration from JavaScript. We're actually going to talk a little bit about JavaScript later because there's some wild stuff there. But anyway, template literals. So what is this? What is specified in PEP 750? Basically, there is a new syntax in Python, which is a T string, a T prefix on a string. And beyond that, the syntax is the same as F strings, as far as I understand. I hope that's right. I'm sure someone will fact check me in the comments, but I've spent a bunch of time playing with this, and as far as I can tell, it is exactly the same as F strings, but with a T prefix. And as we saw before, when we make a T string, do this as well. When we make a T string, it is going to produce a template object. It's not going to produce a string, but it's going to produce a template object. And the idea is that you would write libraries around this template object in order to do interesting things. Now, what interesting things might those be? I have a few examples that I've decided to show you, and these are going to be relatively incomplete because these support all of the various, we'll talk about this later as well, because these support all of the various like modifiers and formatters here. Like bang R is to make a repr here, and you'll see that it actually shows up inside this interpolation object. Getting all these right is a little bit fiddly, so I'm going to show you a very, very simplified version where we just don't deal with any of these. We're only going to be dealing with normal templated variables, and that'll just make the example simpler. Okay, so the first one that I want to show you is a SQL query generator. Now, I guess, I should probably talk about the whole point of this. The whole point of this is to allow you to basically make safer ways of dealing with strings and data. And so one example that comes to mind is, well, if you made a SQL query with an F string, you'd end up with SQL injection. But with a template string, you can make a processor that takes that template and safely turns it into either a parameterized query or, well, I mean, that's probably the only safe thing to turn it into. And so we're going to show an example of making one of those template processors to make a SQL query out of a T string. For that, I'm actually going to copy a database. Where does that live? Cache, precommit. So if you don't know, precommit uses a SQLite database to, what is it, .schema? Yeah, uses a SQLite database to keep its internal state. And so there are two tables here. We'll probably play around with this repos table, which also, again, implementation details, but this is how precommit maintains the location that it checks things out at, and versions and other stuff. But we're going to play around with this particular database. So let's actually make a little example here. SQLite demo, and we're going to be dealing with T strings here. So I'm going to leave out a few of the type annotations just because this is a video, and yeah. Yeah, we're going to leave out the return annotation there. SQLite 3 from string.templatelib import template. I said we're going to leave out the annotations. This one's kind of important, the demo of the video. So we're going to put that one there. I'm going to leave the implementation for a second, but you can imagine something like this. db equals SQLite3.connect, connect, db.db, and run query. We're taking a db, and we're going to take in some T string here. We're going to write a query here. And so let's say we did select star from repos. I don't actually remember the column, so hold on a sec while we look at the column name here. I think it's rev. It might be ref. It might be ref. Okay. So select star from repos where ref equals value. We're going to substitute that in here. My editor also doesn't understand this brand new syntax yet, so it's going to highlight it as if it were just a format string where you would do .format value equals, which obviously you wouldn't do that because that's a SQL injection. The entire point of this is to avoid SQL injection. But let's say value equals v4.2.0, because I think I saw that one in the output. Okay, so this might be exact how you would use something like this. Let's result equals this, and I don't know. Print list result. That way we can actually see this run. I'm pretty sure we're going to call execute and it's going to return a cursor iterator thing. And I think this works. I don't know. We'll find out. Okay, so basically what we need to do in our little template processor function is we need to take in that template object and turn it into a safe query. Now, what we're going to do here is we're going to take all of the string parts. We know those are all literal values that were written in the source, so those are all safe. And we're going to build them up together. We're going to take any of our interpolations and substitute them with a question mark, as you would do if you were writing a parameterized query. So let's just say parts equals this. Template objects have a very convenient iterator. I say convenient, but we'll actually talk about this later because I actually think it's an unfortunate part of the design, but we'll get to that in a bit. You can iterate over them for O in template, and this will iterate either the string parts or the interpolation parts. And so you can check on those and do something based on those. So if is instance O stir, this means it's a literal part, then we can just do parts dot and O. We also need to have params as well, because we're going to interpolate things. Otherwise, if it's not a string, it's going to be one of those interpolation objects, and we need to append a question mark into our query. So this is going to turn it into a parameterized query. We also need to keep track of that param. So params.append o.value. Note that I'm skipping the formatting nonsense here. I'll show you that later. It makes this a lot harder to understand, but this is the simplest way to talk about this. Okay, so finally we have the parts of our query. We have our parameters. Let's run it. So we can just do return db.execute and empty string.join parts and params. So this will make a parameterized query, pass along the parameters, and execute in our database. So this is the basic idea of how you would write a template processor function. Let's run this, make sure I didn't typo something, and show you, I guess, sort of how it works. Empty list. Okay, let's pick a version that actually exists. 1.5.2. I guessed wrong. I think it did when I was playing with it on stream though. Yeah, okay, so you can see here, it did generate a query. Actually just put a print here to show the query. Since I think that's kind of neat to see. So you can see that it transformed the query into this from our template literal. And this seems pretty cool. Like, you know, I don't have to write a parameterized query. This sort of magics it for me. And we get, you know, a safer, nicer syntax that allows us to do it like this. Now, granted, I actually don't think this is significantly better than doing it the manual way, which return results equals db.execute, you know, manually writing out. Of course, you could use a ORM or whatever. Like, I don't think this is too terribly bad to actually write this out like this. I don't know that this actually saves you that much. It's cute, but I don't know, this doesn't seem terrible to me. Anyway, so this is one example that I wanted to show you, a parameterized query generator based on taking the template parts and substituting them with question marks. Another example that I wanted to show you is an HTML escaping library. So let's say HTML demo. Again, from string.templatelib import template. We're also going to import, it's called escape. It's an escape function built into Python. And you know, I would probably use markup safe for this, but standard lib. Let's just make a function called h, which is going to safely turn our template into HTML proper output. We're going to take in our template, and we're going to return a string. Again, we're going to have that same pattern as before. Parts equal parks. Parts equals this for O in T. If is instance O stir, then parts.append O. Otherwise, parts.append HTML. Oh, we already have it imported. Escape O.value. And so if we print, let's say we have, let's say my name for some reason is Anthony script alert 0 writes code instead of my normal name. And we wanted to maybe produce an HTML template, which, I don't know. Welcome to my website name. Maybe we even bold the name. Well, we probably use strong because bold is deprecated or something. But you could imagine something like this where you could actually write out a full HTML template and use a little helper function around it to properly escape the values and not have an XSS problem, cross-site scripting. Okay, so here's an example, another use case where template strings might make a lot of sense. And again, if we run this and hope I didn't typo it, none. I forgot the return. I forgot the return. Return empty string.join parts. None. Yeah, of course. So you can see here that it properly escaped the HTML inside of my my data here. This is another case where we're safely separating the literal code that we wrote and the user supplied, user generated content that may contain unsafe stuff that we don't want to just run as code in our output. Now, if you had done this as an F string instead, you could see that this would be unsafe because we would literally write a script tag into the output, and we don't want that. That's the entire thing we're trying to avoid here. Cool. Another example that might be, and I'm not going to write out the full code for this, but another example that might be nice for this is dealing with translations. Maybe you're using ngget text, and I have, well, we don't have to use the ngget text syntax. I have n, I don't know, apples or something, or n adjective. This is going to be a bad translation, but oh, and this is non-plural. I have one adjective apple. I have n adjective apples. I don't know, something like this. You can imagine like having a translation library which understands these templates, and you don't have to do template formatting that way. You could probably write a logging library too, where you're separating your data directly and dealing with templates. One that I saw being thrown around that seems like a bad idea is a shell library. I actually wrote a version of this on stream. It's probably in a file called t.py. Yeah, this seems like a bad idea to me. But here's another example of where you might be able to use a template to run a shell. I think running a shell using a template string, you're asking for trouble here. This does actually sort of seem to work though. Again, basically taking the untrusted data and wrapping in schlex.quote, and then theory you have input proper argument. I would never do something like this. This is, shell equals true, and I'm screaming and crying and hoping you're doing something else and not one of my coworkers. But yeah, but this is a valid example, and when I ran this, you can see that foo.text safely avoided running a subshell, which we were just going to do. Subprocess.call with shell equals true. This would have put the contents of Etsy password in this file. We wouldn't necessarily want that. Okay, so I've showed a few examples of basically how you would take a template and turn it into running code that safely separates the data. I want to talk about the good parts of this. The good parts of this new syntax. The first is that it's pretty fast relative to trying to do this some other way. The reason this is faster than other ways is this parsing happens inside the interpreter. You don't have to write a runtime parser to take a string and split parts apart and all the error-prone delues with parsing there. The interpreter handles this for us, and the interpreter is written in C, and so this part is relatively fast. So that's kind of nice. Of course, it depends on how you actually implement your template function, because you could make it slow by actually parsing the string parts, but I think that kind of defeats the purpose of this feature. Like, the whole point is that you already have the string parts separated out. You wouldn't like apply a SQL parser to this other part to do more fiddly bits here. That just seems like a source of bugs and not in the spirit of the thing. I mean, you could do whatever you want. I'm not telling you what to do. Another part is that the syntax is fairly compact. This is the shortest number of characters to express this particular set of code. I showed earlier how you would write this with a parameterized query. Yeah, you have to type a little bit more, like you have to make a tuple, you have to put your question mark here, you have to do a lot of manual stuff. So this is short. Yeah, short and to the point. You know, if you were doing the HTML example, you know, if you were dealing with markup safe, which is a popular library for this, markup safe, you would have to write something like markup safe. Well, let's just take the whole markup safe. Markup, not an F string, with respect to T string, so it's not just straight up XSS here. You would have to do markup safe. And again, there's an error prone thing here. Format name equals name. So this would be sort of the equivalent if you're using the markup safe library. Of course, markup safe is going to parse this, you know, turn it into knowing that this is a placeholder, call HTML escape on this part, and then jam it into the string here. So it does equivalently the same thing, but this is, you know, significantly shorter. I say error prone because if you do this, oops, you have XS. Why can I not say cross-site scripting today? I'm just gonna say the damn word. This is, you know, you have a problem. You've done it wrong. But let's put this back in case don't want somebody to just look over and see that on your screen. Okay, so the syntax is very compact, which is kind of nice. I also think that they made a really, really good call by separating out the actual templating part to a function and not having it be part of the syntax. I actually think this is something where JavaScript made a really poor decision with their like tagged template literals. If I can find, oh, why am I scrolling through this? This is not the one that I wanted. Where are their crazy examples? There's some really wild stuff that they show off in here. Yeah, okay, so they start introducing tags here, and they show, where's the quirky parts? I must have scrolled past it. But basically you can like nest tags in like a very weird way. Oh, here we go. Tag functions don't even need to return a string. And they show these examples where they have a, did they get rid of the more complicated one? They showed one where a template string can actually be a template string that's a template string, which is terrifying. But I think separating out, you know, having a first class piece of data that you can pass around and like nest these things or deal with them separately rather than having to do it all eagerly in a particular function call makes this much more flexible. It gives it a lot more opportunity to treat template as a chunk of data, oops, and handle that separately, which I think is a really good design decision here. They could have done what JavaScript did and then we wouldn't have that flexibility, but because these are, you know, actual objects that you can construct and pass around, I like that. It makes this more usable. Okay, we talked about some of the good parts. Now I want to talk about some of the bad parts. First, I think this is going to make error messages a lot worse. For instance, let me show you what happens if we made a typo inside this little SQL demo here. We get sort of a really difficult to debug error message. Well, it's easy to debug because I printed the query, but if you don't print the query, this is really hard to understand what's going wrong. And maybe this is just like my template's not great, or like you would actually need to step into a debugger and see what query it created. And you know, we don't see the query because it's left out in the stack trace. Like I find that the error messages for this tend to be pretty poor, are pretty hard to understand. But you know, this could be improved with a better, you know, query processing library or whatever. Maybe that's not a problem. And honestly, you could probably make this same mistake with just a normal query. So maybe this isn't worse, but it seems a lot easier to make it have bad error messages here. The other is there's a lot of boilerplate to implementing these templates. I talked about earlier how I wasn't actually handling all of the format bits here. Let me show you what it would take to actually handle all of the format specs properly. First off, you need this convert function. And basically everyone is going to have a copy and paste exactly this same function. There are 3 conversions that are supported in F strings and in T strings. I've literally never seen someone use bang A, but it is, oops, bigger. I've never seen someone actually use this, but you can have thing equals world and hello thing bang a, which will ensure that equals hello, which ensures that the thing inside here is ASCII. So if we had set thing to 2603, our snowman, or 1F643, upside down smiley face, and you made an F string with thing bang a, it's going to produce, well, that wasn't what I expected it to do. I guess it produces the escaped version of it, which is, I guess, one way to convert to ASCII. But anyway, I've literally never seen bang a, but it is a thing. So that's what bang a is. Bang r is super common. I see this all the time for converting a value into its representation. So for instance, we just do f thing, you're going to get the literal string. If we do bang r, it's going to put it in quotes. What the repr of thing is. Yeah, those look the same, but trust. And then there's s. I also never see this used. Literally the only one I ever see used is r, but these are the three that are supported. And so if you're going to make a compliant formatter, you need this convert function. So first we have to do, I don't even remember the structure of these. Hold on. Let's look at the docs for it. PyDoc string.template_lib.interpolation. For the name expression or value expression conversion format spec. Okay, so we're going to use conversion here. This here. So you would have to do value equals convert o.value conversion. And then you need to use the format spec. So you'd use value equals format. Fortunately, format is built in Python. Value o.conversion and then o.format spec. And you would have to append that into here. Yeah. So now this will, like, you'll basically have to write these two lines anytime you're dealing with a value, which I find kind of clunky, a little bit annoying. It would be nice if this convert function were exposed, because everyone is going to have to write essentially that same thing. Or even a helper that does convert and format at the same time, because this seems pretty common that you would need to do this. So that seems a little bit strange to me, a little bit annoying, a little bit of extra boilerplate you have to do, but I guess most people aren't going to be writing these template libraries. They're just going to be dealing with someone else that wrote one. And so this is really just on the library maintainers that'll have to deal with this little wart. I wanted to show you a few little quirks. We're still on the bad parts. A few little quirks of the syntax here. Because it supports all of the same syntaxes that f strings do. So if we do like thing equals world, if we do f string hello thing equals, there's this debug f string which produces the same, it's kind of a shorthand to say like keep this string in the output and then show the repr of this, the bang r of this. And so this is how you would do it in f strings. T strings support the same thing, but it's a little bit weird in how they get implemented. It kind of makes sense, like I understand why it's done this way, but you can see here that the string actually gained this chunk from the interpolation here. So this got folded directly into the string, the meat parts of this template object, and then automatically R was added here. Which seems a little, I mean, it's a little quirky. I guess you just have to understand that that's how it works. But it seems kind of different, a little bit. It's definitely an edge case. And they do call this out in the PEP as an edge case, but like, it seems a little weird. There's another thing that's a little bit strange with these. There is a way to do, let's say width equals 10. There's a way to double format or interpolate the interpolations in f strings. So if we did like hello thing width, this is how the syntax works. It's really clunky. So this should align, this should left align. Maybe we want right align. Right align? This should right align whatever thing you're interpolating to whatever dynamic width that you want here. The parenthesis. Yeah, so you can see here, like we set width to 10, if we set width to 5, and we back on one line. Well, 4 is not a great example. Let's do 20, make it bigger. So there's this sort of, and this is just f strings. We're not even on the t strings part here. F string supports this nested interpolation here where you can use interpolations on the actual format spec. And T-string supports the same thing. And kind of like in my mind, when I think about T-strings, everything is lazily evaluated except for this. These interpolations are not lazily evaluated. They are eagerly evaluated. So you can see here, our format spec, rather than it being a template, is actually just eagerly evaluated here. I don't really see this being a problem per se. Just don't take this as user input. I guess is the takeaway here, because you know, if you needed to do something, I mean, I don't know why you would ever need to escape something in an interpolation or in a format spec, but this is eager, which seems strange to me, but it is what it is. Another kind of quirky thing is you can nest these. Yeah, I mean, it's similar to how you can nest f strings. You can also nest these with putting f strings in here. I don't know why you would do this, but you know, I have the wrong number of curlies somehow. Oh, I have 2 curlies and I only need 1. Oh, now it's gone. Hello, hello, thing 1 1. What do you mean? What have I messed up here? Oh, we have the second string, right? So this is this quote here, and then this is this quote here. There we go. So you can end up with nested templates. And I guess this is probably something else that every template library would have to deal with, because presumably someone might want to do a template of a template. I can't think of a good reason to do that though. But it is supported, so it's another little quirk here. Okay, and I want to talk about what I think is the worst part of this. The worst bad thing of this, which is that the whole point of this feature is to make things safer. And I find that it's way too easy to accidentally do the wrong thing. For instance, if we take our SQLite demo here, which is now, I guess, fully featured, deals with all the format spec, like, you know, correct implementation of this. T-strings are so subtly the same as F-strings that this is way too easy of a mistake to make here, using F instead of T. So do this, but rest. And annoyingly, this just runs. We didn't pass a template into this, despite the type annotation here. But because of the iterability of template, you know, you iterate over a string, you're going to get strings. And so this actually just works for normal strings here, which is a little bit spooky. Like, maybe I wouldn't have, like, it's certainly convenient that iterating a template gives you its parts, but I would have maybe made this a little bit safer by requiring you to go through an attribute to get all the parts out. Now you could write your template function by looking at the dot strings and dot interpolations and doing the iterability yourself, but because the convenience exists, you might as well use it. I just think it would be slightly better if it were done this way. But the bigger like highlight here is that I think this, you know, these look very similar to each other. T and F, they're very similar to each other. I think a lot of people are going to make mistakes on typoing these or missing an encoder view or similar stuff. Now, of course, you can prevent this entire class bug by using a type checker, but we all know not everyone uses a type checker. So I don't know. I'm a little worried about this. I think that people are going to make this mistake a lot. But yeah, hope it's fine. But let's put it back to not broken. Yeah. And of course, I also had to modify this particular example to put bang R here. But you can imagine if this were like HTML, you wouldn't have that mistake. Like, you wouldn't have to change the value here. You would just be splatting it right into the template. Open yourself up to cross-site scripting. Okay. All right. Let's talk about another bad thing. So we got this new type from string.template_lib import template called capital D template. It turns out there is already a string.template, and it is not. Oh, wait. It is not the same as string.template.lib.template. So this is probably just like a very minor thing, but I think this is going to be pretty easy to confuse with these. And I imagine I'm already going to have to put a linting rule that's like, no, you used the wrong template in your type annotation and have to deal with auto rewriting to something like this. But you might ask, Anthony, what is this other string.template? Which brings me to the last bad thing. And maybe this isn't a bad thing, but this is just, making a bad thing worse, which is that there are too many damn ways to template strings in Python. Let me just show you a few of them, including string.template. If we go for the oldest one, we've got percent formatting, which lets you jam strings together. And again, this template strings are a little bit different than this because they have to deal with data separately. So this is a little tongue-in-cheek, but we got %s, or your percent formatting. You've got your dot formatting. You've got your f strings. This looks silly, but and now we have our t strings. There's yet another way to do this. Well, I say yet another way, but we also have string.template, which takes $sign variables, very different from how you would see it in the rest of Python. And then there's a substitute, world equals world. So yet another way to do templating. And this is actually very similar to the new template lib stuff, which is it gives you a common interface to write something against a interpolated string, and then you could override substitute to escape the values. Looks very similar, smells very similar. And actually there's yet another way that's very similar to template strings in Python, which is, what is it called? Is it the formatter? Yeah, I think this one, f.parse. This string.formatter actually implements the same meta language that .format does, and similar to fstrings. Actually, my fstring hack used to use this thing, and PyUpgrade uses this to upgrade fstrings, or upgrade format into fstrings. But this actually, we gotta show you the list of these. This actually produces, let's make it more interesting. This gives you a set of tuples which look very similar to the parts that get put into our t-string up here, which is that you have your string part, you have your value, you have your format spec. One of these is format spec and the other is the conversion. And so again, we have string, value, format spec, conversion, string, value, conversion spec, conversion. Let's put a conversion on one of them so I don't look a liar. Yeah, well, I should have put it on this one. So it's not wrapping around the screen. But yeah, this string formatter is very similar to what template lib, or the new template t strings provides. And you could imagine building a generic template library on string.formatter in the same way that you would build a template library on t strings. So it feels like this is yet another way to do things with a little bit of confusion, and we're not getting rid of the old ones. Which, I mean, Python suffers from being 33 years old, 34 years old, however many, 91 years, somewhere around there. And so, yeah, it's grown some of these many ways to do the same thing, kind of in contradiction to the Zen of Python, which is there should be one obvious best way to do things. Now, I guess the obvious best way to do things is f strings and t strings, but we should get rid of the other ones. Okay, so I've shown you the syntax, how you would use it, how you would write libraries for it, the good parts of it, the bad parts of it, and now the part that you don't care about, which is what I think about it. I think there are some cool parts to this. I definitely think this is going to enable some cutesy syntaxes and potentially some ways to do things safer. I think there are some problems with the way it's implemented, some of the things that I've highlighted above, and some of difficulties with how you would actually write it out. And ultimately, I don't think Python needs this syntax. Maybe that's controversial. I think you could get by with a lot of the other ways of doing this. Write your own string.formatter, write your own string.template. Yeah, it's not going to be as compact as the syntax that T-strings provides, but maybe that's a good thing, because I think T-strings are going to be way too easy to confuse with F-strings, and you're going to have to be looking, you're going to be squinting real close to make sure that they are actually T-strings and not F-strings in code reviews. So overall, like, I don't think Python should, it's too late for me to test this. Like, it's already a feature in the language. It's already going to land in Python 3.14. It's already been accepted as a PEP. It's already been implemented. But I don't know. I think Python keeps adding syntax without really, really strong use cases. And yeah, I think this is yet another one it's going to be used by maybe 5% of users. And that to me doesn't seem like a strong enough reason to include it in the programming language. But that's just my thought. It doesn't have to be yours. I hope you found this useful. My goodness, this is a long video. There was a lot to explain, a lot of demos to show off. I hope you found this useful, and if you have additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.